So far, we have studied about the preparation of alkanes and physical properties of alkanes. Now, we will discuss the chemical properties or the different types of reactions of the alkanes. Although alkanes are mostly inert, that is, they are very less reactive, but still they do undergo some types of reactions like substitution, oxidation, etc. So, now we will see the reactions of the alkanes. So, chemical properties of alkanes. Okay. So, the first one is oxidation. Now, within oxidation, we will study three types of oxidation. One is complete oxidation or combustion. The second type is incomplete combustion. And the third type is controlled oxidation. Okay. So, the first one is complete oxidation or combustion. What is combustion? That is, alkanes on heating in the presence of air or oxygen are completely oxidized to CO2 and water along with evolution of heat. So, when alkanes are heated in the presence of air or oxygen gas, they are completely oxidized to form carbon dioxide and water. So, carbon dioxide is the complete oxidation product of alkane. If we oxidize any alkane, doesn't matter which one it is, all alkanes on complete oxidation will give carbon dioxide and water. So, there is a general formula for the complete oxidation of alkanes. There is one general formula. Okay. So, what is the general formula? CnH2n plus 2, right. So, this is alkane plus 3n plus 1 divided by 2, this many equivalents of oxygen. It will give, upon heating, n number of CO2 in the gaseous form and n plus 1 water in the liquid form. So, this is the general formula for the complete oxidation of alkanes. Okay. Now, let us consider n equal to 1. What is n equal to 1? That is methane. Okay. So, n equal to 1, that is CH4 plus how many oxygen? If we put n equal to 1 here, then 3 into 1, that is 3, 3 plus 1 4, 4 divided by 2, that is 2 oxygen gives N, that is 1 CO2 plus N plus 1, that is 2 H2. Along with it, there will be a heat of combustion, which is written as delta CH. Heat of combustion is minus 890 kilojoule per mole. Why negative? Look, in chemistry, we study any quantity with respect to the system. We study the system. So, when energy is absorbed by the system, that is, energy is entering the system, we consider it as positive. And when energy is leaving the system, we consider it as negative. So, in combustion, heat is generated, that is, the system is liberating the heat. Heat is transferred from the system to the surrounding. Since heat is leaving the system, we consider the heat produced in combustion as negative. Okay? So, this is the heat of combustion. Okay. Now, let us say N equal to 2. N equal to 2 is ethane. Okay. So, how many oxygen is needed? N equal to 2. So, 3 into 2 is 6. 6 plus 1 is 7. So, 7 by 2 oxygen in presence of heat gives 2 CO2 plus N plus 1, that is 3 H2O. Okay. Similarly, if we take propane, then C3H8, that is propane, plus 3 into 3 is 9, 9 plus 1 is 10, 10 divided by 2, that is 5 oxygen. It will give 3 CO2 plus 4 H2O. So, this is the complete combustion of alkanes. Now, we can see that heat is generated in combustion. So, due to evolution of large amount of heat, so this heat generated is a huge amount. So, due to evolution of large amount of heat during combustion, alkanes are used as fuels. Okay. Since large amount of heat is produced by combustion of alkanes, so alkanes are used as fuels, that is the source of energy. Now, the next type of oxidation is incomplete combustion. When does incomplete combustion occur? Incomplete combustion occurs when there is insufficient amount of air or oxygen. Okay. So, incomplete combustion can be of two types. For example, the first one is 2 methane plus 3 oxygen gives 2 CO, that is carbon monoxide, plus 4H2O. This is carbon monoxide. Okay. Carbon monoxide is very toxic, very harmful. So, why this is incomplete combustion? So, see, in complete combustion, one methane require 2 oxygen, right? So, 2 methanes will require 4 oxygen, but here see 2 methane is having 3 oxygen. So, the complete combustion is not able to occur. So, instead of carbon dioxide, we have carbon monoxide. Now, why is carbon monoxide so toxic? You may know that in our body, hemoglobin binds to oxygen, and that is how blood supplies oxygen to our body. But the affinity of carbon monoxide with hemoglobin is much higher. Hemoglobin is more attracted to carbon monoxide than oxygen. So, if there is 2 options, oxygen and carbon monoxide, hemoglobin will always bind with carbon monoxide. So, the oxygen supply to the body is stopped. That is why carbon monoxide is highly toxic for our body. So, this was one type of incomplete combustion. The second type is CH4 gets 1 oxygen. Now, that is even less than the first reaction. So, methane gets 1 oxygen, then it will form carbon black, that is carbon in solid form, plus 2 H2O. Okay. This is called carbon black. Carbon black is used for the manufacture of ink, black pigments, etc. So, the third type of oxidation is controlled oxidation. Controlled oxidation. So, what is controlled oxidation? The name itself says that the oxidation is regulated. So, alkanes on heating with regulated supply of oxygen or air at high pressure and in the presence of suitable catalysts give a number of oxidation products. Okay. Alkanes on heating with regulated supply of oxygen or air at high pressure. So, regulated supply, high pressure and suitable catalyst. These are the conditions for controlled oxidation. So, by oxidation of alkanes, what are the types of products that are possible? Alcohols, that is ROH, aldehydes, RCHO, and carboxylic acids, that is RCOOH. Okay. So, among these three, the acids are the most oxidized form, then aldehydes, then alcohols. So, alcohols are the lowest oxidized form. So, we can guess that for conversion of alkenes to alcohol, we will require lesser amount of oxygen, and for conversion of carboxylic acid, we will require the highest amount of oxygen. So, the first process converts alkanes to alcohols. Let us say methane in presence of half equivalents of oxygen, and what is the reagent here? Copper at 523 Kelvin, that is high temperature, and 100 atm pressure, that is very high pressure, it will give methanol. Okay. So, if we write it little properly, so 2 methane, 1 oxygen in presence of these reaction conditions will give 2 methanol. Now, the second one. Now, a little more amount of oxygen. So, there was half oxygen, now 1 equivalent of oxygen will give formaldehyde or methanol, or this is also called formaldehyde. Now, what is the reagent here? MO2O3, that is an oxide of molybdenum. This is the conversion of methane to methanol. The third one, now some more oxygen again, methane plus 3/2 oxygen. It will give methanoic acid or formic acid, and the reagent here is manganese diacetate. Okay. So, if we write properly, 2 methane plus 3 oxygen in presence of manganese diacetate will give HCOOH. Okay. So, if we write with ethane also, 2 ethane plus 3 oxygen in presence of manganese diacetate will give acetic acid or ethanoic acid. Ethanoic acid or acetic acid. So, these are the controlled oxidation reaction of alkanes. We will study about more reactions of alkanes in the next lecture. Thank you.